Hello and welcome to the webinar. Today's topic, Beyond DevOps, using AI to get Kubernetes NoOps. This event is brought to you in partnership with Opsani and produced by Actual Tech Media. My name is David Davis of Actual Tech Media, and I'm excited to be serving as your moderator. Before we get started, there's just a few things that you should know about the event. First off, we want this to be educational. We encourage your questions, and we'll be doing a live Q&A session at the end of the presentation today, so keep those questions coming. We also have our best question prize for a $50 Amazon gift card, which will be awarded after the event. So if you have a question on your mind, make sure that you get it in early. We also have a number of resources available in the handouts tab that you should be aware of, specifically a link to the Opsani Virtual Labs environment. So make sure that you check out those resources. And then finally, we'll have the winner of our Amazon $300 gift card door prize announcement at the end of the presentation today. All prize winners, of course, must meet the Actual Tech Media Prize terms and conditions, which can be found there in your handouts tab. And without further delay, let's kick off today's webinar. I'm excited to be joined by Peter Nikoloff. He is the co-founder and CTO of Opsani. He's a virtualization and cloud workload technologist and a cloud and DevOps pioneer. He previously founded 3Terra, which was acquired by CA Technologies, now Broadcom, where he implemented one of the first successful cloud platforms, deployed at companies such as BT, CenturyLink, and Disney. Peter is a prolific inventor and has issued over 28 patents. Excited to have Peter on the event. Also joining me is Eric Kalasa-Kenyon, Opsani's Director of Machine Learning. Prior to joining Opsani, Eric worked on precision GPS, climate model systems, and agricultural microbiotics. Now, Eric leads Opsani's machine learning team to deliver a flexible, effective optimization engine. And then finally, we're also joined by Mr. Sean Isom. He's an engineering manager from Adobe. Sean manages the efficiency engineering team for Ethos, which is Adobe's container, compute, and CI/CD framework. Ethos runs Kubernetes across a global network of on-premises and cloud providers that run thousands of Adobe's online services. Previously, Sean was responsible for Ethos's migration from DCOS to Kubernetes. Sean is in New York City and comes from a background in aviation and Windows C++ development. Thank you so much for joining us, Peter, Sean, and Eric. It's going to be a great event here. Let's go ahead and kick off our discussion with our first question. Our first talking point here is, why do you want to achieve NoOps, and exactly what is NoOps? Peter?
Thanks, David, and thank you for having me. There's a lot more to be done with cloud. I mean, cloud has been around for a while, but we have just scratched the surface of what is possible with this technology. What operations teams used to do with screwdrivers and patch cables and KVM switches, in the cloud, we now do this with APIs. So even when various operations actions are performed with a web console by a person, they're still executed by APIs. So the question that I want to preface this is, well, what lies beyond the web consoles and simple operational automation that you can achieve with scripts or if then else kind of statements? The opportunity that is provided by the cloud in form of these APIs that can execute deep and very complex operations is not just remote control, what we have, like I sit in my chair instead of going to the server to add more memory. I can do that without getting up from my chair. It goes a lot beyond that. It goes to full autonomy. It is the opportunity there is to make further changes in the way operations works, to empower DevOps to focus more on the features and capabilities of their products than on programming automation rules or handling corner cases in operations that their prior rules didn't support. If you look at what is out there, for example, AIOps implements some of these very interesting and advanced cases by using big data And what AIOps does is mostly about visibility and analysis of what is going on, so that the operations teams can very quickly get to the root cause of problems. However, that process still relies on people to process and interpret those signals, and to take, more importantly, to take remedial action. And they're also reactive. They tell you when things kind of go wrong. NoOps, on the other hand, is kind of a parallel track that takes this further into providing autonomous responses that can remedy these problems. And in the most interesting cases, it works proactively to even prevent these problems from happening, and achieve optimal user experience without disruption. So that's the primary reason, is achieve optimal user experience without having to have developers and DevOps engineers constantly looking and dealing with these systems. Now, let's look at one very important example. When you look at DevOps, DevOps has automated a lot of the routine tasks like building and testing, and even rollouts have been fully automated, sometimes even with rollbacks. So that kind of process has been streamlined. And yet they still require significant manual work in handling failures and performance and optimization. For example, let's take performance tuning. That used to be routine for every product release before DevOps and before that automation. And if you look at a typical CI/CD pipeline, you have manual build, you have automated build, you have automated testing, and then there's deployment. There's this gap that happens in the middle between testing and deployment, which used to be tuning. And again, everybody who has worked on these systems before remembers that we used to spend weeks sometimes on performance tuning and optimizations. And that is not easy to automate. There's no simple rule, there's no script or sequence that you can execute. So the result of this is those tasks are, with today's velocity and speed and everything being automated in that pipeline, what happens is that these optimization steps are simply not being performed. And the result is that DevOps teams deal with optimization only when things break, which is not the best way to do it. Otherwise, there's just not enough time in the day to be able to do this for every release, for every microservice. So, for example, as a first step in NoOps, this optimization can be performed autonomously and continuously after each deployment. And that completes the workflow and leaves a lot more time to the DevOps teams to work on adding features and do kind of more deeper tasks, and without sacrificing user experience and costs.
Thanks for clarifying that, Peter. So I want to move on to kind of a follow-up question here, and that is, why can't this be done by hand? Why can't it be done without AI? Eric, you want to chime in on that?
Sure, thanks. In short, we need AI for flexibility. Realistically, all real-life ML-based applications are hybrid systems of both, heuristics, expert systems, and pure non-parametric machine learning models. We use the heuristics to cover our sort of known bases. We have application performance tuning experts in-house, and we encode some of their knowledge in these heuristics, and that helps us stub our toes less when we're getting started, which, machine learning models with absolutely no prior knowledge would do a much worse job of. The ML components add the flexibility to account for apps that don't fit our heuristics or whose application performance characteristics are, different from what we expected a priori. So that gives us an update function. Settings we've not planned for, and dynamic application behavior over the course of application lifetimes. We can account for those.
Excellent. Thanks, Eric. Let's move on now to another question, and this one's for you, Sean. How has what you've found out about Kubernetes and AI resulted in a solution for you over at Adobe?
Thanks, David. Well, I guess let me start with a bit of a description of some of our history with containers and our Kubernetes platform. Obviously, scaling and reliability are some of Adobe's biggest challenges with our online services. Adobe's kind of been on this journey to the cloud over the past decade, and containers for us have really, over this time, we've moved from, the initial, like, let's put it in a data center, let's take traditional apps and turn them into services. Let's wrap them with VMs and put them in the public cloud. And now we're, with our latest incarnation of this, we're really focused around containers. And so this is where the idea of the Ethos platform came from for Adobe. And so Ethos is Adobe's container compute framework that right now is based off of Kubernetes. And really the kind of the beginning of this was the, there's a group within Adobe called Behance. It was the startup that was acquired by Adobe about 6 or 7 years ago. And Behance had these build nights where they're, they take their latest version of their code and they'd throw whatever test they could at them, and they'd sit in a room with a couple of pizzas and try to push it to production and hope nothing broke, right? And so obviously we needed a better way to do this. And so we've, over the course of the last 6 years, put together tools, specifically a CI/CD tool internally that runs on top of GitHub and GitHub Enterprise, and clusters, so we can actually run these services in a kind of standardized way. And so with all that, all that started with Behance. It quickly became a standard across Adobe as we really pushed to use the containerization use case in production. We started having those conversations about 5 years ago. And I'm happy to say by now, by and large, we're not having the conversations. Our containers ready for production. Obviously, the community and the industry is really standardized around Kubernetes since. And so, over the course of the last 4 to 5 years, we've scaled from our first production services to thousands of production services now, as we run over 80% of Adobe's infrastructure. So that's kind of the background on the platform and containerization. Specifically on Kubernetes, we've reached a point where we actually started with containerd, just running as a framework, and moved to Mesos, which is a very popular container orchestration framework before Kubernetes. We did the migration to Kubernetes about a year and a half ago, and this was very much a planned move. And if actually you look over here, you can see our kind of canonical architecture diagram, and in that you see the CI/CD and the onboarding tools that I mentioned. But what's important is we were able to design the system so it ran regardless of what orchestrator is working in the background. So like I said, we used to use DCOS, which is a wrapper around Apache Mesos. Through just a DNS-based transfer with appropriate, changes to our deployment tooling, we're able to largely swap out the container orchestrator under us. So, looking ahead, we've very much standardized on Kubernetes, and it's very important for the future of us as a platform, as now we're able to continue to grow that based off of community-based solutions. Kubernetes is only getting more popular in the DevOps space. So we're very excited about the capabilities that's unlocked for our next generation of scaling. And speaking of scaling, that's where some of our platform's biggest challenges come up these days. And so that's where tools like AI are becoming very important and very relevant to us. We now run multiple cloud providers, data centers, dozens of regions. We have over 125 Kubernetes clusters currently that we manage. And like I said, we have thousands of applications just running all of our products on them as we move more and more into microservices. So, we're just kind of getting started with the DevOps and with the NoOps approach to DevOps, and starting to incorporate AI into our practices over the last couple of years. But it's critically important for our future. As Eric mentioned, we're able to look at heuristics and look at previous usage and come up with very simple predictive models. But when you scale to thousands of services, both for performance and for reliability, nobody's able to keep eyes on these numbers at the same time. So for us, we're using, we've looked at tools like Opsani. There's some other reliability tools our Adobe research division has put together, and AI is only becoming more and more powerful and more important as we go forward.
Very exciting. It's really amazing to see how you all are using this at Adobe, this new NoOps architecture. I mean, I would love to see this in action. I know a lot of the folks watching the event, of course, would as well. Peter, is this something you can show us?
Yes, absolutely. Yeah, thank you, David. Here's what the Opsani Web Console looks like. It is optimizing at the moment one very typical Kubernetes application. And it's a live application receiving varying amount of traffic, just like any application normally have daily ups and downs. And what you can see here is that the traffic level for the application, and then the cost, and then response times and error rates, which are service level objectives that we need to achieve. And what Opsani does is it takes a period of time through which it performs optimization. It automatically runs experiments and makes sure that it can try various configurations in a very, very small area of your application, like a canary. The same concept as canary, but trying different configurations. And over time, under different traffic conditions and different performance scenarios. And as it goes through the process, it tracks down all the metrics, everything that is involved in both kind of controlling the amount of resources that the application has, settings, as well as the metrics. What are the results of that operation? And we provide a lot of information here, but the decisions are made autonomously. What you can see here, for example, is that so far, just through several iterations here, Opsani has found a significant amount of savings by reducing resource use that is needed. And it was able to do that while maintaining the service level objectives, which is running the median response time, as well as the P90, which is kind of the marginal response time of the application, pretty much within the same numbers. So, and then keeping the error rate at firm 0. And through the experimentation process, it goes and tries. Sometimes it will try something that's a little too tight and it will get feedback. It's like, no, don't go there again. On the other side, it may try a little bit more resources and it will see that, hey, adding more resources, things are not getting better, so let's not do that. So this way, it is able to find the best, the optimal configuration, and then provides information and has capabilities of applying that configuration. One of the super interesting things is that this is not a one-time thing. There's a bit of a change here in the way optimization is done when you have DevOps and kind of a continuous deployment and integration with very frequent releases. Instead of doing optimizations in kind of discrete moments, optimization can run continuously. So many things can change. Your traffic patterns can change. Your application obviously changes as your engineers are building in additional features that they may require more resources, so we need to up the resources in order to maintain the service level objective, or they may introduce an optimization, so now your application may need a lot less memory, and we will find that and kind of reduce the cost and increase the efficiency while maintaining the performance and the user experience. So the effect of continuous optimization with this system, as you see, is being able to run most efficiently while maintaining your performance and user experience.
Very cool. That's awesome. I'm excited to see this in action. I know a lot of people on the event are as well. So thank you so much for sharing that with us, Peter. So with that, I want to move on to, just kind of wrapping up some closing words here before we start our Q&A session. First off, to you, Peter, what do you want folks to know out there about NoOps and Opsani?
Oh, I think we covered a lot of the important elements, which is why you need to do NoOps, why this is the direction, and then why AI and machine learning is really enabler for the next wave of DevOps and improved efficiency and capability and increased velocity, as well as maintaining awesome user experience for your customers.
Awesome. And Eric, why should folks look at this instead of just manually tuning their applications?
Right. If you are a large team with one application that is updated very infrequently, you can probably manually tune. If you have enough pizza and enough evenings in the build room. But when you're dealing with limited engineers and lots of applications and even less time, you need something that will scale to those conditions. And automation does that. If you have a variety of applications, then you need something that's a little more flexible than your standard expert system or some heuristics. And that's where AI comes in.
Awesome. And Sean, any final closing words?
Yeah, absolutely. Well, as our platform and our business continues to scale, we're going to keep pushing Kubernetes and really the entire container technology stack to its limits. So tools such as AI will only become even more powerful and even more necessary to really unlock the next phase of growth. Like Eric mentioned, there's only so much that can be accomplished manually.
Excellent. And I mean, I would love to get a hold of this. I know a lot of companies out there would as well. Peter, how can customers get access to the Opsani solution?
It is very easy. We offer what we call virtual labs so that you can try the Opsani technology for free. In these labs, you can see the demo of our product, and then you have a sandbox that allows you to go through several optimization processes, make some adjustments, see how things work out. And then after you're comfortable with that, you can onboard your first application and optimize it and see what Opsani can do for your application in your environment.
Awesome. Well, I'm looking forward to trying the Opsani virtual labs out for myself. And I know that's going to be a hot topic for folks to take as their next step from this event. We've placed the link to the Opsani virtual labs there in the handouts tab of your audience console. I encourage everyone to check that out. And with that, thank you to Peter, Sean, and Eric for being on the event today. We're now going to go into a poll question and kick off our live Q&A session.
There's one more thing, David, that I would like to add. I just learned that just for trying our labs, we'll send you a free Yeti cup.
Excellent. All right. Thanks, Peter. All right. Great discussion. I really appreciate that. And I've just brought up a poll question for everyone out there in the audience. I want to call your attention to the poll that's on the screen that says, would you be comfortable with your company adopting NoOps? Simple yes, no, or maybe you just need to learn more about it and how it works. So I encourage everyone to respond to that poll, and we'll start answering your Q&A right here, or your questions right here. So let's see. First question I wanted to ask. This one is for you, Sean, I believe, and then maybe someone else, Peter or Eric, wants to chime in, and that is from Bradford, who's asking, is this a case of replacing personnel with AI or ML for efficiency?
Yeah, certainly. From the Adobe perspective, we're not replacing personnel. I'll throw that out there for sure, right? All of our automation is around making our personnel more effective. So we want to be able to, take what they've done, take what engineering resources do, and up-level it to be able to apply it at scale. So, for us, it's mostly a matter. It's definitely not a matter of replacing personnel. We're always trying to scale up our teams. It's about directing them where the engineering effort is most required.
Excellent. And Peter, what about from other customers? What do you hear about this concern about replacing staff with AI and ML? Is that the case or not?
No, this is not what we're seeing at all. What we do see is that because of the high velocity of releases, people, engineers simply don't have time to run optimizations and to tune their applications. So we are essentially covering a gap that is currently completely not being filled. So it's not replacing people, it's doing the work that doesn't get done. And at the same time improving kind of reliability and user experience.
Got it. Okay. And then next question here, they're asking, will AI NoOps be useful with virtualized workloads? Can this help there, Peter?
If by virtualized workloads, you mean workloads that are running in virtual machines, then absolutely yes. This is already happening for EC2 type virtual machines and just cloud virtual machine level. And it also applies, and our focus is specifically on Kubernetes and containers So definitely.
Excellent. Yeah, it's great to know that it can help really kind of all around there with different types of workloads, no matter how they're packaged. Let's see. Next question from Bradford. Does Opsani monitor and manually tune the parameters that AI and ML does not adjust appropriately? For example, is it completely hands-off for on-prem staff? Who wants to take that one?
I can cover that as well. So there's ability for the engineers to configure guardrails and say, don't go under 2 CPUs or don't drop the memory below this level. And they can also define additional parameters that they want to configure. So there is control. There are some things that just work out of the box and don't require any kind of human configuration so that they become effective immediately. But the engineers can definitely specify guardrails and add additional parameters that they want to optimize, kind of change some of the optimization goals, targets, specify their SLO targets, and so on. So what the ML tries to do is detect and identify as many things as possible automatically, so we can actually discover the desired service level objectives automatically. But engineers can always override these decisions and specify explicit values for things that they want to do.
I like that. That it's not just
add to that.
Please
sorry,
do.
I was just gonna say I think I can add to that a little bit as well, right? It's all the same things that you normally do when you're monitoring an application, right? You're looking at red metrics, you're looking at error rates, you're looking at duration, you're looking for signs of an obviously unhealthy application, like restarts or 503s for a web-based application, for example, right? And so those are just part of the feedback loop, right? And so you want those to inform any decisions you can make about your application's performance or life cycle. And so, the kind of AI NoOps approach is just taking that and, being able to feed in from that at scale. So you're not just responding to PagerDuty all day, every day.
Yeah, I like that it's not just a black box that, you don't know what's going on inside, and this AI has taken over. Engineers always have the option to tweak the knobs there to tune, the monitoring and performance of their applications. So thanks for clarifying that. I want to call again attention to the poll on the screen. If you haven't answered that, now's the time to respond, because we are moving on to our next poll, which is simply, what additional information would you like about the Opsani solution? Do you want to try it for yourself with the virtual lab environment that Peter talked about? You want to get a personal demo, or maybe just some additional information? We want to hear your feedback on that. It's a multi-select question as well, so feel free to select more than one answer. Let's see, next question from the audience. They're asking, can we tune and optimize the cloud resources which were provided to result in cost savings? Is there a potential for cost savings with Opsani?
I would
Peter,
probably ask Sean to look at that as well.
Yeah, so
yeah, Sean.
I mean, obviously, cost savings is the goal, right? With any optimization effort. So yes, you can tune, you can optimize. The end goal is reducing resources, reducing waste specifically, right, while maintaining the performance characteristics of an application. So yes, certainly.
Excellent. I like that. I mean, any tool that you can use to generate some real cost savings could help to offset the cost of the tool, and just help the business across the board. So very cool to hear that. Next question. Let's see. How can this optimization be incorporated back into a version control system? Is that possible with Opsani, Peter?
Absolutely, yes. So there's several ways in which we can kind of propagate the results back. In kind of the simplest case, we would just talk to Kubernetes API and affect the changes. We also have what we call a GitOps connector, which is, I think, what you're asking about, which allows us, instead of applying the changes directly through Kubernetes, for us to check in or even create a pull request for the configuration if you're using a GitOps type system where the configuration is stored and versioned with version control. So absolutely, this is possible, and it's one of the scenarios we support.
Very nice. And Sean, I'm curious, are you guys at Adobe doing anything where information is brought back to version control or anything else?
Not actually at this time, right? And that's because the optimization is very dynamic, right? So depending on the results of the workload. But what we do store kind of as infrastructure, as code in version control is kind of what the baseline resources are for an app, right? So that's kind of the contract. You can get up to that amount of resources if you need them, but we'll squeeze what we can of waste out of you dynamically in the meantime.
Okay, I like that. Yeah. Let's see. Next question from Gilbert. How do you craft checks and balances? Is there some way to watch the watchman when it comes to AI ops?
Absolutely. So the first aspect is part of kind of the contract that our server, which is the agent that lives in your environment, has. There's configuration there that allows the engineers to define guardrails. I think I mentioned that. So you can define maximum cost, maximum number of instances, as well as maximum resources, as well as minimum resources. So that allows to kind of constrain the exploration space and also make sure that things don't go out of bounds for what you need to do. In addition, we have our web console and our API through which you can obtain a lot of this information and include that into monitoring systems as well.
Can I add on top of that briefly? I
Please.
mean, we also spend a lot of time making sure our safety models are good. So we can look at SLO violation rates and control those. This is something that's important to us to make sure that we are watching while we're optimizing, so we don't violate your performance standards.
Smart. I like that. And then I know we talked about how Opsani can help to save costs. There's another question here they're asking about, kind of specific examples, or, is it by provisioning spot instances or detecting over-provisioned resources? Could you provide the cloud resources which Opsani currently supports tuning? Are there any more details that you can provide on that?
Sure, I can take that. So we don't deal with spot instances. The kind of the cost of the infrastructure is like we work with what you have. If you use spot instances, we'll save you money off the spot instances. If you use regular instances or you have an enterprise license, that gives you slightly different pricing. What we do is we reduce in terms of the cost. We reduce the workload footprint. So this is completely orthogonal independent. It works together with solutions that like spot instances, for example. So what we do is we reduce the workload footprint, which is the amount of CPU, the amount of memory. So even let's say if we have customers who are on-premise data centers, and that gives them more capacity in their data centers so that they can grow without adding additional servers. In cloud systems, of course, yes, you have the opportunity to to reduce your number of instances, the cluster sizes, so that this saves you money. And in addition to this, when we modify settings, we can also get performance advantages and improvements that are not directly related to costs, but as a result, you will be able to handle higher throughput or achieve better performance with fewer instances, which indirectly affects cost as well.
Excellent. And then next question here, I know we talked about integrations maybe with a CI/CD or with a version control system, but the next question they're asking about existing application integrations. Are there any other integrations that are commonly used or that are possible that you want to talk about, Peter or Sean or Eric?
Sure. So the way our server works is it's plugin based. So we have different connectors for different systems. Most systems are pretty straightforward, and they work immediately with Kubernetes, Prometheus. They're pre-configured to attach to kind of most common systems. We have different or editions or flavors of the product. So the simplest one is we would actually collect metrics by injecting an Envoy sidecar. So we don't need to find where your monitoring system is, what metrics you have. Then you can start off and kick off optimizations immediately. For kind of bigger systems where injecting sidecars may be too much, or the system is a little bit bigger, using our connector architecture, we can connect to any monitoring system, and we support App Dynamics, we support Prometheus data, we support several different monitoring systems, and as well as kind of control and CI systems that you can attach to. So there's kind of something that works out of the box very quickly and very easily. And then we have additional integrations that we can do to kind of tune and attach the system better to your environment.
Very nice. Yeah, a lot of different options there for integration. Let's see, next question for you, Eric. They're asking about, they say, isn't automatic performance tuning dangerous in a production environment? Like, could this negatively impact performance in some way?
Honestly, yes, it can. I mean, if you're going to tune anything, there's always a risk of, let's say you've got a fixed Java heap size for your memory, and we don't know beforehand that exists. Any tuning is going to risk hitting that memory threshold, right? But we've built our business around doing as little disruption as possible while still performing what is categorically, a somewhat risky maneuver, but we minimize the risk as much as possible. That's a core business objective.
Yeah. And the way, thank you, Eric, this is good. You mentioned earlier the safety provisions in our algorithms that allow us, when we discover that something lowers performance, to stay away from those configurations. In addition to this, one of the ways we work, especially in live environments, is by injecting what we call tuning instances. So when we make configuration changes, we don't change the application as a whole. We run these kind of verifications and tests on just a side instance, which is very similar to the canary approach that is used in DevOps and in CI/CD deployment. So the changes, or kind of the danger, affects a very, very small proportion of the traffic. And we also have a very good detection of when things kind of are not performing as well. So we can back out that change and remove the tuning instance. So the footprint, or the amount of traffic on which these changes are applied, is very, very small. It's a fraction. It's just a single instance. Again, that is very much in line with what you're already doing with CI/CD.
Excellent. And then, Sean, this question's for you. I'm curious to know the answer to this one as well. They're asking, why did you implement your own Kubernetes instead of using tools like EKS or AKS from a cloud provider?
Yeah, that's a great question. So, it comes up a lot because, EKS and AKS are very cheap, designed to kind of be very easy to work with out of the box. I think at Adobe, we evaluated these several years ago and basically came to the conclusion that due to some of our security controls and how we do upgrades to clusters and basically the version management of Kubernetes and the core infrastructure components of it itself, we decided that it made more sense to roll a consistent EC2, well, basically raw compute-based version, depending on the cloud provider, that's kind of consistent across cloud providers. But what I can also share is that's kind of evolved over the past couple of years, and we are now actually looking to migrate a lot of our clusters to EKS and AKS as they have kind of matured their operational practices at the cloud providers. So, I would say if you're looking to get started with Kubernetes, EKS and AKS, and I guess GKE throw in there as well, they're all great solutions, very easy to get up and running with.
Awesome. And I know we're starting to run out of time here in our allotted webinar slot. So we've answered a lot of questions. We've got a lot of great questions from the audience. I want to call everyone's attention to that poll one more time. If you haven't responded to the poll, we appreciate your feedback on that. And Peter, I wanted to ask you just for a little bit more details on the virtual lab and the getting started here with Opsani. If we click on the getting started with Opsani link and create an account, can you kind of tell us what happens after that?
Yes, so creating an account actually provisions a fully working account with Opsani with an optimizer. So as you log in, there's obviously links to documentation and things that you can kind of examine and understand. You can look through our dashboard, and then there's three things that you can do. The first one is the account comes with a pre-provisioned live demo application, which you can think of it as a sandbox. It is something that is actually optimizing, and you can see how it works. You can see the dashboard. You can look at the configuration. You can start it, stop it, kind of change the objectives of the optimization. So you can really explore what Opsani does, and do that relatively quickly without having to connect it to your application yet. So it's just kind of a very easy way to get familiar with Opsani and understand better what it does. And then you can onboard your own application. There's a button that you can click, and then you can attach an optimizer to your own application. If you have something running in Kubernetes, then you can attach it and just see how it works. People do that in staging and test environments, obviously as an early stage, but it works in production environments as well. And then for the case if you don't have an application that's handy that you can try, we offer a virtual lab, where we will actually give you a setup of a reference application called Bank of Anthos, which is a very traditional microservices application by Google. It's used a lot to train Kubernetes. So we start with that application. We give you a copy of that application, and then you can attach Opsani to that application and optimize it and see how it works. So these are the three main options. Is you essentially can explore using the live demo, which is like a sandbox and gives you the ability to play with it and understand it. You can optimize your own application when you're ready, and then you can use our virtual lab to attach to a reference application.
Very cool. It sounds like something I'd like to try out for myself. I bet a lot of folks on the event here would as well. Great, cool solution that we're learning about here on the event today, using AI to get Kubernetes NoOps. Peter, Eric, and Sean, it's been great having you on the event. Thank you for your discussion and all your wisdom shared on this topic.
Thanks, David. Thank you, everyone.
Yeah, thanks very much. Great to be here.
Thank you.
And thank you to Opsani for supporting the event today. Don't forget about the free trial link that's right there in your handouts tab. Just click to get started with Opsani, and you can try out this solution for yourself. I'll leave the poll question up for anyone who hasn't responded yet while I announce the winner of our Amazon $300 gift card door prize. That is going out to Jared Risser from Missouri. Congratulations, Jared Risser from Missouri. Thanks to everyone who joined us on the webinar today. I hope that you learned a lot. I hope that you have a great weekend. And of course, check out opsani.com for more information. Take care.